Let's talk about the limit of a function. The limit of a function f of x as x approaches or tends to a value a is written as the limit of f of x as x approaches a value a. This is equal to f of a. Look for the limit of this function 2x squared plus 3x minus 7 as x approaches 1. What do? This is simply equal to, in place of x here, I'm going to write 1. So we have 2 times 1 all squared for this plus 3 times 1, 3 times 1 minus 7, and this is equal to what? 1 squared is 1, times 2 is 2, 3 times 1 is 3, minus 7. 2 plus 3 is 5, 5 minus 7 is minus 2. So the limit of this function as x approaches 1 is equal to what? Minus 2. Watch this video to the end. Remember to like and hit on the subscribe button for more videos, okay? So what is the limit of this function x squared plus 1 all over 2x cubed minus 1 as x approaches minus 2? In place of x here, I'm going to put minus 2. Minus 2 all squared plus 1 all over 2 times minus 2 to the power of 3 minus 1. Okay? Minus 2 squared is 4 plus 1 divided by minus 2 to the power of 3 is minus 8. Minus 8 times 2 is minus 16 minus 1. Alright, let's go ahead. 4 plus 1 is 5. Minus 16 minus 1 is minus 17. So this is the limiting value of this function as x tends to minus 2. So what is the limit of x squared minus 4 all over x minus 2 as x approaches 2? When solving limit problems, you have to be very inspective. By inspection, if I plug in the value of 2 into this, I will have 2 squared, which is 4. 4 minus 4 is 0. The numerator is 0. If I plug in 2 here, 2 minus 2 is 0. So this is 0, this is 0. If direct substitution leads us to a 0 all over 0, we usually look for another method of solution. Now, since direct substitution led us to a 0 over 0, let's see what we can do to this function to reduce it further. This is actually a difference of 2 squares. That is the limit of x squared minus 2 squared. 4 is 2 to the power of 2 divided by x minus 2 as x approaches 2. Okay? So what is this equal to now? This is equal to the limit of this x squared minus 2 squared by difference of 2 squares is equal to x minus 2 times x plus 2 all over the x minus 2 at the denominator as x approaches 2. Good. X minus 2 can take away x minus 2. So what we have now is just x plus 2. That is the limit of x plus 2 as x approaches 2. So if we now do our direct substitution, if I plug in the value of 2 here, it will give me 2 plus 2, and that's equal to 4. So the limit of this function as x approaches 2 is equal to what? 4. Let's see some more complex problems. Keep watching. Alright, what is the limit of this function 8x plus 9x squared all over x times x squared minus 9 as x tends to 0? Okay, Now, we must be very, very smart. If we plug in the value of x here, which is 0, into this function, it will give us a 0 over 0. Check. Plug in 0 here. This is already 8 times 0, 0. Plug in 0 here. 9 times 0, 0. 0 plus 0, 0. So we have 0 at the top already. If I plug in 0 here, of course, 0 times any other thing is 0. So I'll have 0 at the bottom. So we have to do away with this 0 over 0. So what we'll do now is to simplify this expression further to avoid having a 0 over 0 at the end. Now, if I look very well, I can factor out x here to cancel out this x at the bottom. This is what I'm saying. The limit as x approaches 0 of x is common to these two, so I can bring s out, open a bracket. 8x divided by x is 8. 9x squared divided by x is 9x. So this x can actually remove this x. So we can obtain the limit as x approaches 0 of 8 plus 9x upon x squared minus 9. So we can now plug in the value of x here, which is 0, into this function to obtain the limit. So the limit will now be equal to 8 plus 9 times 0 divided by 0 to the power of 2 minus 9. Okay, this is 8 plus 0 all over 0 minus 9. Of course, 8 plus 0 is 8. 0 minus 9 is minus 9. So we can actually rewrite this as minus 8 over 9. So this is the limit of this very function as x approaches 0. Keep watching. Alright, let's compute the limit of this function. 16 minus x divided by 4 minus root x as x approaches 16. By direct substitution, if I plug in 16 into this function for x, 16 minus 16 is 0. Root 16 is 4. 4 minus 4 is 0. That will be 0 all over 0. And we don't need a 0 over 0. So let's find another method to achieve the solution. Now, this expression is a surd. We can actually rationalize the denominator of this surd by multiplying both numerator and denominator by the conjugate of this denominator. This is what I'm talking about. The limit as x approaches 16 of 16 minus x all over 4 minus root x. So rationalizing means I'll multiply the top and the bottom by the conjugate of this bottom. 4 minus root x. The conjugate is 4 plus root x. 4 plus root x. Alright, let's go ahead. So we have the limit as x approaches 16 of multiplying these two in form of bracket is 16 minus x times 4 plus root x. Okay? All over. Let's expand this. 4 times 4, 16. 4 times root x, 4 root x. Minus root x times 4, minus 4 root x. Then minus root x times root x is minus x. And this is equal to the limit as x approaches 16 of 16 minus x, 4 plus root x divided by 4 root x minus 4 root x we cancel out. What we have left is what? 16 minus x. Very good. 16 minus x can now cancel 16 minus x. So we are already at the verge of getting our answer. So the limit of 4 plus root x as x approaches 16 will now be 4 plus the square root of 16. Replace x with 16. Good. Now, this is 4 plus root 16 is 4. 4 plus 4 is 8. Good. So the limit of the function as x approaches 16 is equal to what? 8. So just stay tuned as we go through the series of limits of a function. I'll see you in the next video.